Hi to all, welcome to this new video tutorial on ixCube. We are working actually on release 2.2.3 where a few new features are available for those that have the advanced mesher. I am sure a lot of you remember the boundary group in Forten 3000 and Forten 4000. So today we have a tool that is very similar to the boundary group but a bit more powerful. Let's see how it works. I'll go into the CAD tools. Let's create a new CAD layer. So let's say we want to cover a space. I will use the polyline tool. I want to cover this space here like that, and then again with the polyline tool I will draw another area like this, and then another one like this. So this is very similar to the boundary group in the form of Forten 3000. This new tool is a bit different. We select all these polylines and we recall the tool sew and merge tensor groups. It is clear that this tool will use the advanced mesher. It asks for the mesh size and automatically 3 tensor groups are created over that mesh. So this is a very, very powerful tool, but it's even more powerful, and let me clear these and start a new job. Here in Rhino I have drawn this these 4 arches, space frame arches, so these are supposed to be my steel work, and we want to membrane under these arches, and everybody knows where is the problem. Most of the time is to connect the membrane to these points. These points are fixed points, so the mesh, our membrane mesh, has to go exactly into these points so everything works fine. So I will just copy my model and paste it into ixCube. At the first moment I will just select the boundary and these 4 polylines, these 4 layers, sorry. In these layers the 4 polylines, base polylines of the arches. So I just import them as CAD layers. Close with OK, and these are my polylines. So we just select them, we go into the FEM tools and recall sew and merge, the mesh size 1, and that's it. We have the mesh created on the fly. That's nice, but we have to think that if we recall now boundary mesh, there is a new tool, all mesh boundary. All mesh boundary will make all the tensor groups, all the boundaries of all the tensor groups in one shot. So I just click on apply, and you see we have generated the boundary edges of all these mesh groups. We still have duplicates, so I need to recall find duplicates and I will delete them. So basically we have generated the mesh and we have the edges of this mesh. The last thing is missing is my steel work. I will just paste again, but now we will input the arches as FEM2D and the cables as FEM groups. So you see everything is inside. So the only thing we have to do now is to set properties for these. Let's start assigning the properties to the membrane, and this is a pre-constrained membrane. We set the wipe and the weft in the current X zeta plane. Okay, so the membrane is done. Beam elements, linear, stiff, and 88 millimeter. So they're all These elements are all beam elements. Again, the arches, these are again beam elements, linear behavior, stiff, and 88mm. So we have set the properties for the beams. The last one is the cables. These are cables, non-linear, they are stiff deformable, and 16mm cable. So we have assigned the properties for all the elements. Last thing to do is to set the restraints for these elements. So we can easily select these nodes. Let's look from front and go into wireframe, so it's easy to select these nodes like that, and we fix them. So we have fixed these nodes on the ground. Let's see if everything is okay. This one here, so we fix it. Okay. Okay, so fix them. Okay, so we have fixed the nodes, assigned properties, we save, and we run the form finder. One step for the NFDM form finder. In the non-linear analysis we can leave 10 steps with 0.1. We run OK. The model has converged, and that's the final model. As you can see, the membrane is perfectly connected to the steel, and now you can go into the plots and give a look at the membrane stresses, and we see the membrane stresses. Oh, this has lost a little bit pre-stress here. The middle membrane has lost pre-stress. This beam element is quite low stiffness, so it has bent. Anyway, for the sake of this example, it's okay. And then we can give a look at the axial forces. The axial forces over the beams. So, thanks for watching.